Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. This is simpler using machine learning algorithms in R. And so we're in Unit 6, Chapter 6 if you will, and we've been learning about linear discriminant analysis. And this is Lesson 2, and we're going to be focusing on preparing the data so that we can develop our models and test our models in the next 2 videos. So without wasting any further time, why don't we go ahead and go over to R. And so here is our data, not our data, but here's our code right here at the top. We're going to be using the ECDAC library. This has our dataset star inside it. The maths library has our linear discriminant function, if you will, and the core plot is for visualizations. So I'm just going to go ahead and run this line, load my data, take a look at the data. So what we're going to do here is that we're going to use math and reading as well as total experience of the teacher to try to predict the type of class that the student was in. So there are 3 types of classes: regular, small, and with an aid. And so we have 3 categories that we're trying to do our classification for, if you will. And we're going to use some of the continuous variables. Yes, there are other variables in here, but they're factor variables, and the function, the LDA function doesn't like factor variables. We could, of course, make adjustments and change it and all that stuff like that, but we're just trying to do the basics here, so we're not going to do that. So in line 4 here in my code, if you will, my script, I'm going to set my seed. And now we're going to take a look at some visualizations here. So here are the math scores. Looks pretty normally distributed to me. Here are the reading scores. Still looks pretty good as well. And then here are the total experience. And you can see here we have a little bit of problem. It makes sense that most teachers would have very little experience. Teaching is quite the challenging profession. And you can see here that as time goes by, there are fewer and fewer teachers who are sticking around, where by the time you get to 25 years, no one's left teaching practically. So we could do some data transformation on this. Remember that normality, especially multivariate normality, is kind of important for discriminant analysis. So here in lines 12, 13, and 14, here's what's happening. In line 12, we take our star data, and then what we do is that in line 13, we transform the particular variable. So the problem here is the total experience. So this is what we're going to do. Do this, and now we're going to transform it. So let's see here. This is what we're transforming right here, and we're loading this into the star square because I don't want to do this in my original data set. The original data set is star, so I copied over to star.sqrt. This is star square root, and then I transformed that one variable by calling it total experience for the teacher.sqrt. That's what I'm doing here. So I do this, and then we do histogram, and you can see it looks better now by taking the square root. This is one way to transform it. It's still not perfect, but it's much better. Now we want to get an idea of the proportions of our dependent variable. So keep in mind that there are 3 categories. And now this is kind of important because when we actually develop the model, we have to tell the function or the algorithm what we expect the a priori for the various probabilities for each of the groups. So I do the probability here, and you can see we have the 3 categories, like I mentioned, for our dependent variable, which is class type, if you will. 35% of the data is regular class, 30% of the data is small class, and 35% of the data is regular with an aid. That's kind of how it works out. And of course, we can also take a look at our correlations for our continuous variables, which are going to be our independent variables. And so we gotta first take the correlations, and then we're going to make our visualization here. All right. And so you can see that it's very faint. There's one high correlation between, right here, one high correlation between math score and reading score, but the other correlations are very faint. Again, for our purposes, this might not be a concern. 0.7 is relatively high. You might want to reconsider that, but we're just exploring this for purposes here. And so the last thing that we need to do is we got to scale our data because often with classification algorithms, they're sensitive to scale. Not all, but often that's the case. And so what we do here is in lines 23, 24, and 25, we scale our independent continuous variables. So I scale math reading. I scale right here, looks like reading. And then also I scale the teacher's experience, the square root of the teacher's experience. That way everything's on the same scale. Sometimes if they're not on the same scale, the ones that have the higher values have more influence on the algorithm and the classification. Now lines 26 to 28 should look very, very familiar. We're just splitting our data into training and test sets. I've already explained this several times, so I'm not going to deal with it a whole lot, but again, we split our data into 70% train, 30% test. And since I've already explained this several times, we'll just press Control Enter and do it all at once. And the data preparation is essentially completed. And so in the next video, we will actually do our model development and take a look at the results of the various coefficients for the linear discriminant analysis function, our functions that we will see. So in this video, all we did was prepare our data. It's not that complicated. You should be very comfortable with this by now. We did, we loaded our libraries. We set up our visualization. We had to transform one variable because it was having some issues there. Teacher's experience. Then we took a look at the proportions inside the dependent variable just to get an idea of what to expect, and also it'll be important when we have to put the prior probabilities inside the model. And we made the visualization here off to the right to get an idea of what it looks like. And then we split our data, which is we scaled the data first, where everything is on the same range. This helps the algorithm to perform its functions, its job, and then we split the data into training and test sets, as we've done several times. So again, I hope this video was useful for you, and that you're able to be comfortable with how to prepare the data for this particular chapter. My name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler, Using Machine Learning Algorithms in R. Take care.